ambiguous case of the law of sines. It's the ambiguous case of the law of sines. It's me again, by popular demand. The one case in trigonometry that I ask students about, and depending on who they took the course with, or they say they never understood this part, the angle side-side case, or the side-side case of the law of sines, the ambiguous case. The three different types of answers you may get when you're given two sides of a triangle and that non-included angle. So here's angle side side, angle side side, angle side side. With the ambiguous case, you'll get three different solutions. Thank you so much. So what happens here is, let me show you. No solution, one solution, two solutions. Students say, it's so confusing, I don't quite get this. Well, let me break it down for you. So, like I said, feel free to watch this video, pause it, rewind it, watch it again. When students say, well, I can't learn, I learn better face to face. Well, that's because your little butt's sitting in a seat in front of me for an hour and I'm standing over you pulling that alpha male stuff. You know what? Just watch this video again and again. Watch it 3 times in a row. Invite your friends over. Have a Daniel Price party. Watch me all night long if you have to. So here we go. Ambiguous case with the law of sines. No solution. Let me show you what happens when you have this angle side-side and you get a no solution. It's pretty obvious. I'm going to use the law of sines, which is the sine of 50 degrees is to 1, and I'm going to find this angle. The sine of x is to 2. So that's the law of sines. So now I'm going to simply cross multiply. I get the sine of x times 1 equals 2 times the sine of 50 degrees. Now since 50 degrees, it's not one of the 16 points on the unit circle, so I've got my dandy calculator. I'm making sure that the mode is in degree mode. And so I'm typing in 2 times the sine of 50 degrees and press enter. And I get the sine of x equals 1.532. Now, this is a trigonometric equation, so we want to solve for x. So an easy way is to take the inverse sine of each side. So what I do is I take the inverse sine of the sine of x, but whatever I do to one side, I do it unto the other. So I take the inverse sine of 1.532. The inverse sine of the sine of x is simply x. And then I type this into the calculator. Second sine activates the inverse sine of 1.532. And I get an error. It says error domain. Oh my, this is no solution. But come on, people. We should have known this. We should have known that this was going to be no solution right from the get-go. Because when we think of the sine of an angle equaling a number, let's go back and look at our sine function, the little wave. It bounces between 1 and -1. 1.53 is above it. Also, keep in mind that in a right triangle, sine is opposite leg over the hypotenuse. Leg over hypotenuse, that's always going to be less than 1 in a right triangle, And finally, don't forget the unit circle itself. X squared plus y squared equals 1. X squared plus y squared equals 1. If this is the y value and you square it, isn't that already greater than 1? And then you're going to be adding x squared to it as well, so even if it's 0, it's still. So that's 3 different ways to explain that we should have recognized in trigonometry that this bad boy had no solution. Plus your calculator will tell you. Second example, let me do the law of sines again. So I have the sine of 40 degrees is to 3 feet, as I'll find this angle again. I can call it theta, beta, ABC, whatever. So this is the sine of x equals 2 over 2. So when I cross multiply, I got 3 times the sine of x equals 2 times the sine of 40 degrees. I'm going to divide both sides by 3, and I get the sine of x equals, using my calculator, I'm going to be a little careful. I'm going to type in 2 times the sine of 40, press enter. then divide it by 3. And I get 0.4285. I'm now going to type in second sine of 0.4285, and I get roughly 25 degrees. Not exactly, but I'm going with 25 degrees. So that's 25 degrees, that's 40 degrees, so that would be 65, so 115 more. We can find that third one real quick. Okay, one solution. Now let me jump to this one. If I do the sine, and I'm going to find this angle, once again, being consistent, sine of 35 degrees is to 6 as the sine of x is to 8. I'm going to cross multiply. This is 6 times the sine of x equals 8 times the sine of 35 degrees. I'm going to divide both sides by 6. So now I'm typing in my calculator 8 times the sine of 35. I'm pressing enter, then dividing that by 6, and I get 0.7648. Second sine, 0.7648, and I've got roughly 50 degrees. Now, the calculator told us very quickly why this one was no solution. But looking at these two answers, you're saying, well, how do we know which one has one solution and which one has two there, Dan? You can memorize some stuff in your textbook if you want to. You can memorize what the side lengths and angles, or you can do what Daniel does. I know I'm dealing with the angle side case, the ambiguous case. I need to be prepared mentally for these three answers. This one's pretty obvious. I don't know which of these should have one solution or two. I've already got one solution right there. I've got 50. So in other words, this is 25, and this would be, let's see, that's 65 again, that's 115. So this one right here would be 50. So 50 plus 35 is 85. So we need what, 95 more? And there's your triangle. But which of these has two solutions? This one does. And you're saying, how do you know, Dan? Take the supplement of 25. Take the supplement of 25, which is 155 degrees. Because they add together to equal 180. But if I take the supplement, which is 155, and add it to 40, I'm at 195 degrees, which is more than what the triangle can add. The three angles have to add up to equal 180. So I know this one only has one solution. What's the supplement of 150? 130. So in other words, this other angle could be 130 instead of 50 degrees. And when I add these two together, that's 165, which would make this angle 15 degrees. So in other words, my drawings are not drawn to scale. This large triangle would be the 95. The 15 would be this little one. So notice how what happens. We have this angle, we have this side, and then at this side, right here, is a little less than that one. It could be this way or teeter-totter that way. And you're saying, how, Daniel, did you know to take the supplement of that? Who would have thought of that? Who would have thought of it indeed? Let's just get rid of that. When we think about the unit circle, and I were to ask you to solve what is the sine of x equals 1/2, you would say, oh, I'm looking for a y value that is equal to 1/2, and that occurs at 30 degrees. But also remember that sine, all students take calculus, sine is positive in both the first and second quadrant. So when we go all the way around here to this angle that has a reference angle of 30 degrees, 180 minus 30 is 150. The supplement, this 150 right here, this one also has an ordered pair, negative square root of 3 over 2, 1/2. So what happens is when we solve these equations, we have to remember that there are two solutions for the sine of x equaling this number. that are between 0 and 180 degrees. It's the law of sines. Sine is positive from 0 degrees to 180. So not only do we get the one solution, but we also get its supplement. This one only has one solution because the supplement of 25 degrees, which would have made the solution around right there, and the other one right around here. But the supplement of 25, which was at 155, 155 plus 40 was too many degrees. That's over 180, so we know it only had one solution. Here it is right here. Here's that case where you had two of them, where instead of being this way, it could have been like that. Angle side, side, the ambiguous case, look at that right there. 50 degrees supplement was 130. So my recommendation is this. When you solve a triangle using the law of sines, you don't have to worry about it with the law of cosines, because the angles are going to be positive, and with cosine, you're only positive in the first quadrant and the fourth. And in the fourth quadrant, to get there, you've got to be over 270 degrees, which is more than the 180 degrees for the three angles of any triangle anyway. So sine is the tricky case. Using the angle side side recognition, be ready for one of these three cases. See you next time. Law of sines, it's the ambiguous case. Side, side, angle, or angle, angle, side.